Right then, folks, hello and welcome to this brief lecture on linear programming. Now, notice we have done this in the class, and the only reason I'm making this brief lecture is so that it helps you in doing the homework problems, okay? So, I'm just going to quickly go over one of the problems we did in the class and walk you through the steps that we took to obtain the answer. So, what is linear programming? The idea is based on a certain set of constraints. Let's say you have a total amount of land, you have a total amount of beginning cash. You are trying to determine how much do you want to dedicate to each production activity so that you can optimize your profits. Okay, so let's say you are a goat producer, you are a corn producer, how much beginning cash and how much resources you want to dedicate to each of these production activities so you can get the highest possible return. And that's the idea behind linear programming. You can do linear programming by hand, which is something that we did not do in class, but again, doing it by hand is kind of redundant, especially if you have a computer program or a software such as Excel, which can help you do it, okay? So let's sort of go through this question, and I will try and walk you through the steps we took to solve this particular question, okay? So you have a household of team starts working, and it produces its goats, maize, and hay, and some of the farm is often infallible, okay? So the household, so we have 4 people in the household, they farm about 3 hectares of land. For this year, they estimate 115 days of labor is available for them for all production activities, so that is the total amount of labor time they actually have, and they have about $700 available for total production. The team calculates that the goat requires 0.1 hectares of pasture, 7 days of labor, and $49 of the beginning cash reserve. The annual cash income per goat is $330, and then as you will go through, you will notice that you have parameters given, or the resources required to produce goats, maize, and hay. Okay, so then if you recall, we sort of inputted this data in this Excel file here. So notice in this column over here, I have the constraints. You have a constraint of land, that is the total land that you have, the labor time, you have a beginning cash income, and then the end cash income is the expected amount of earning you hope to make from however many goats, however much corn and hay that you produce. Okay? So let's sort of go back and try and populate these particular cells. So notice we have the team calculates that a goat requires 0.1 hectares of pasture. So the constraint for goat then is simply 0.1. We also know that it requires 7 days of labor. So labor is simply 7. And then the beginning cash requirement is 49, which we filled over here. Notice also that right at the beginning, right over here, we had, for the year, they estimate about 150 days of labor is available to them. So in total, your labor amount, which is this over here, is 115. So whatever you dedicate, you cannot exceed 115 as your maximum amount, okay? We also know that in total, you have about $700 of cash available, which we put here. And then as far as land is concerned, you have about 3 hectares, okay? So whatever you decide to do, you cannot exceed the 3 hectare limit, okay? So a hectare of maize would return $1,800 in cash income, okay? So let's say corn, of course, stands for maize, so it would return, therefore the end cash income becomes $1,800, okay? Notice that I just quickly stepped over this point over here, which says that the annual cash income per goat is in fact 330. So we write it here. So again, notice this point, a hectare of maize. Therefore, the amount that you're looking to dedicate to making maize or corn is going to be 1. Okay, this line is key here. A hectare of maize. If a hectare of hay is sold, therefore you're also looking to dedicate about 1 hectare on hay, you would get a return of $300 in cash. So this is 300. The end cash income that you hope to make is $300. A hectare of maize requires $200 of cash, so this is your beginning cash requirement. So this is going to be 200, and then it requires 40 days of labor. So you put 40 days over here. A hectare of hay requires $150 of cash reserve. So the beginning cash requirement is $150, and then it requires 30 days of labor. So you put that over here, okay? Now if you go down here, you will notice a farm family wants to maximize cash available for discretionary spending, cash available after satisfying food and other household needs and necessary cash expenses. At the very least, they need $1,000 of non-discretionary cash at the end of the year. So you are hoping to make as at least $1,000, so that whatever the combination is here, it is at least is above $1,000. So whatever combination of production activities you have, you at least get $1,000 in cash. Okay. So how do we then sort of determine what is the optimal, how many goats you need to produce, how much corn you need to produce, and how many goats you need to produce, how much area you need to dedicate to corn, and how much area you need to dedicate to hay, okay? Based on all available information, you then require Excel to give you some numbers, okay? So how do we sort of pretty much go about doing it? Notice that we're asking about what the goat, corn, and hay is going to be, that is these values over here. So let me just highlight that in a different color. So let's say blue over here. And then we are also interested in finding out these values over here. So what is the individual resource used? So these ones over here. Okay. So let's sort of walk you through the process. Since I'm interested in populating these values, first thing you need to do is you need to find out what the sum product is, okay, for each of these particular cells. So why are we doing this sum product? The point is that you have some end cash income. When you multiply this end cash income with the number of goats you made, plus end cash income with the amount of hectares you dedicated to corn, plus the end cash income times the amount of hectares you dedicated to hay, you are going to get a total amount. You're going to get a total amount which hopefully will exceed $1,000. So this cell is what you're hoping to pretty much maximize, okay? So the idea, just as an example, so let's say 330 times, I don't know, 0.7 plus 1,800 times 1.1 plus 300 times 2, for instance, times 1, for instance, okay? So this gives you a certain amount of value. And all I have done is that I have simply multiplied these. Hypothetically, suppose these are the values we were to obtain, and this 2511 is going to be greater than 1,000, so it is an ideal outcome for you, okay? But the numbers that I just put in, especially over here, these are just hypothetical numbers. We actually want to calculate what those actual numbers are going to be, okay? So therefore you need this sum product formula, okay? So if we just do sum product, you highlight these, okay? And you go comma, and then you go this over here. Now notice, since this is going to be same for all of these, so when you multiply, let's say, this array with this array, don't forget to put a $ in the second array. Okay, so this over here. So check to make that check to see that the formula is working. Hit Control-C and then simply Control-V. So you copy paste it. So you have, for this amount, for this particular cell, F11 to H11, and then comma this array over here. Okay, so you can click on this and Excel will highlight for you the cells you're actually pretty much using for this formula. Okay, and you can make sure that you check for each single cell so that this F10, F9, F8 all are reflected and the change is reflected. You only want the first array to change. The second array, this one over here, is always going to be fixed because these are the values you're interested in finding out. Okay? Then what do we do? You get to this cell, go to data. Now, if your solver is not showing up in your own computer, or if your solver is not showing up in a lab computer, simply go to File, go to Options, go to Add-ins, okay, and then scroll for, let's say, the solver add-in, hit Go, and then you're going to it's already going to be selected, so hit OK, and then if it is not already there, it's going to show up. So click Solver, okay, and then you will see this box pretty much emerge, okay, and then we have to go ahead and sort of go ahead and complete what our objective is and what are the constraints, okay. So notice the first cell over here says set objectives. How do you set an objective? What is our objective? Our objective is to maximize this particular cell, okay. So all you do is you go ahead, click on this, click this, and I'll do it twice, and you're going to see the K11 is, in fact, this is what we are hoping to maximize. Okay, make sure that this here is maximum. What are the variable cells that we are changing? So changing variable cells, click over here, and these three are the ones that you're looking to optimize. So you go ahead, you select this. So it will do $F $6 to $H $6. Okay, so this is what you're going to get. Now you're left with constraints. So if you recall, what are the constraints going to be? Okay, notice the first constraint, of course, is that whatever you get in this cell over here, okay, whatever you get in this cell over here, it has to be greater than this 1000 over here. Okay, so to add that first constraint, hit Add. Okay, so cell reference, this one over here, K11, must be greater than or equal to this cell over here, which is J11. Okay, hit Add, and then you can hit OK or cancel, and then this one over here is already there. You also have to worry about another constraint. And what is that constraint? Hit Add. What you want is that these three values for land, labor, and beginning cash must be less than or equal to these values. Why is that? It's because these values over here, the 3, 115, and 700, these are the maximum potential resource you have. So whatever you decide to use, it cannot exceed the maximum potential resource. Okay, so the cell reference, of course, this over here from K8 to K10 must be less than or equal to this over here, the 3, 115, and 700. Hit Add, and then you can hit Cancel, and you will see that the second constraint has also showed up. Notice that the method of solving should be simplex linear program, and then you're pretty much ready to hit Solve. Okay, so once you hit Solve, it may give you something like this. Keep on hitting Continue, and then you should end up with an answer like this. Now, if you recall, this is exactly what we got in the class. So what is the interpretation then? The interpretation is that if you're using your resources the way you are, these are the resources given to you, you should be making 8.93 goats, you should be dedicating 1.31 hectares to corn, and you should not be dedicating anything to hay. So your portfolio should be about goats and corn and nothing for hay. And then how many resources you're going to use? You're going to use 2.20 hectares of land. You're going to do you're going to use your entire labor days. You're going to use your entire beginning cash. But look at the amount of cash you stand to make if you take this strategy over here. So your total end cash income technically could be $5,308. Okay. So just to sort of go ahead and recap or summarize what this question was about, notice now we have completed the question, but typically the information follows the exercises option follows the information, and you have three particular questions that I'm interested in. Of course, construct a linear programming matrix, and this is the first step that we did. That is, pretty much populating and constructing this table. The second is solve the problem to determine if there is a feasible solution. Okay, and what do we mean by a feasible solution? What does that mean? What that means basically is this idea that, are we getting a number here? Are we getting a number here which is in fact greater than our constraint, and are these numbers satisfying the constraints over here, and does it actually make sense that we produce a certain amount of goats, corn, and hay, and then we get a certain number which is in fact maximizing our overall objective. Okay, so that is what I mean here by a feasible solution. So then, if you get something like that, you discuss and interpret the solution. Okay, so what does an interpretation mean? Well, an interpretation here simply means that, hey, we actually ended up getting something which makes sense. One of the interpretations here, of course, is the fact that even though hay technically should be part of your portfolio, from a profit maximizing perspective, it does not make sense to make hay simply because, and no pun intended, make hay simply because it is not a profit maximizing thing for you. Okay, so that is what I have, and please let me know if you have any questions on the email.